So I want to thank NARUC and Lisa and DOE and NASIO and others for inviting me to participate in today's event. I'm really excited to talk with you about grid interactive efficient buildings. We're about to publish a report from the Building Technologies Office on a roadmap for grid interactive efficient buildings that's going to include things that you all can do to facilitate the use of buildings as a flexible resource in around the country in your regions. I'm going to be talking about the use of automation and how utility programs are using automation. I'm quite familiar with the California programs, but if questions come up, I'm familiar with some of the work in Hawaii and other states. I'll talk about open standards, and that's a big part of my talk, is to familiarize you with the way these standards work, how they're similar, how they're different, and then to give you some details about some of the materials that Andrew McAllister just introduced to you about the load management standards in California, something called SB 49, and the digital price server that the California Energy Commission is developing, and then where we're headed, because this is a really exciting time. We're developing the technology using the internet and other communication systems to be able to continuously communicate with devices in buildings. And we're really excited to present this to you today. Go ahead to the next slide. So many of you may have seen a slide like this before. The basic history in demand side management is energy efficiency. And energy efficiency is about using less energy all the time, less energy anytime. And we're moving away from not just using less energy, but understanding when we use the energy. And I'm mostly going to be talking about electricity. So we have these terms of load shed and load shift. Load shed is your traditional hot summer demand response. And those tend to be events. They may be 1 hour, they may be 4 hours, they may be 6 or 8 hours, but those are event-based activities. Load shift is something that's emerging, and load shift is a big challenge today because we don't have a lot of it in the market, and we'll talk a little about using prices for load shifting. But the basic idea is actually to be able to take load at part of the day and reduce it at another part of the day. So it's moving load, and that load may or may not increase the total energy. So sometimes if we can shift load to a cleaner time of the day and take a little more one time, use a little less in another, the total GHG greenhouse gases may be down, even though energy use might be up. Modulate is the term that we use for fast response. And in the California terms, we use the terms shape, shift, shed, and shimmy. And modulate is like our shimmy resource, where we're fast acting loads, 5-minute or 1-minute response, ancillary service types. And then generation, which is not in one of the pictures, but that's the concept of a building being a prosumer or being able to supply its own energy with a photovoltaic or a fuel cell or even CHP. So these terms are important as we think about the policy constructs to enable the buildings and industrial loads to be part of our flexible grid of the future. Go ahead to the next slide. So really quickly, the concepts of what I just said are starting with efficient components. We really want to understand HVAC, lighting, facades, plug loads, and go to the next slide. And then how you control these as a whole building system. So a lot of us are very interested in whole building retrofits. Go ahead to the next slide. And this next one is how these systems fit together and how either an individual device or the whole building is communicating with some sort of grid signal. Okay, go ahead to the next slide, please. So I want to give you a quick overview of some of the programs in California. California had something called bifurcation years ago. And we have load modifying programs that are primarily communicated to customers with pricing signals, something like critical peak pricing or real-time pricing. And we've been having a series of conversations with the utilities in California about more RTP. So the concept is, if the price is high, can we automate the load to go into some sort of different mode when prices are high? The SoCal Edison RTP is a temperature-triggered RTP. So you can see it's triggered on the temperature in downtown Los Angeles. CPP overall is triggered on temperature. So it's a day-ahead program, and there's some sort of emergency system conditions as well. Now, the supply side demand response programs in California are those that are bid directly into the CAISO wholesale market, capacity bidding, The base interruptible program is, of course, an emergency response. And then something called summer discount, which is direct load control. Now you'll see there's manual and automation, and I'm going to introduce you into some of the automation data. The automation data have been a lot with the large CNI programs, and we're beginning to see some of this OpenADR technology used in the smaller residential as well. Go ahead to the next slide. 3 standards I'm going to talk about. The first one is OpenADR. I'm going to give you a little bit of details on that one. The second one is CTA 2045, and the third one is SEP IEEE 2030.5. A little bit about the history of each. All of these have started around the same time, which many of you may not know. About almost 20 years ago, OpenADR was funded by the California Energy Commission, and we at LBNL have been working on that for almost 2 decades. And we developed a language of grid signals. So OpenADR, I'll go through it in a moment, is basically a software application between utility and the buildings. CTA 2045 is different. CTA 2045 is a hardware and software component. The other 2 are software. CTA 2045 was actually conceived by a researcher in California who had the idea for something called USNAP, which was like a port, a physical port that would also have communication. And the state's been working on that for, as I said, sort of 2 decades now. SEP2 was the newer version of the Zigbee SEP1, which was part of the Zigbee radios and advanced meters. And that one is tending to be used more with Rule 21 and inverter control, but it also has messages that can be used for prices to devices. And when you think about these standards, you can think a little about a Mac operating system or a PC operating system and the need to have a variety of different ways that we communicate. There doesn't have to be a single one. There can be a few, and there's pros and cons. There's no perfect standard out there, but these are some of the most common standards in use today. Go ahead to the next slide. A little bit about OpenADR. OpenADR is a server, and that's what we call the top node, and then an end node, which is at the building. And we put in the end node normally with retrofit gateways. So the OpenADR Alliance now has 160 different members that are supporting it. On the bottom there, you'll see the pricing data models. So an integer price can be translated into an OpenADR signal, and we tend to use the internet. It doesn't have to be the internet. We're also using FM broadcast to send these signals. So the building is pre-programmed to do something. The most common thing we do is to reset the zone temperature. So in large buildings, it's very common that the building may be operating at 70 and we let it go up to 74 or 75 for a couple hours. And we have 1,000 of the target retail stores across the United States use OpenADR and work with their rooftop units. So in some parts of the market, big box retail, there's a fair amount of uptake of this standard. Go ahead to the next slide. Now, cloud interface, I want to make sure you understand the differences. OpenADR, when we first developed it for CNI buildings, we were focused on large, because the Zigbee was really the protocol of choice for SEP1 with smart meters and residential. But at this time, OpenADR is also being used in homes and in smart devices because the technology can go from a utility cloud to a vendor cloud. So it may go to an Ecobee cloud or a Nest cloud. And the cloud interface is very important because the kind of technology that we're using for a large CNI site where we have a gateway receiving the technology and signals directly is very different from the vendor clouds that we see in residential. So that's an emerging capability. A lot of smart home devices are capable of receiving OpenADR signals. Go ahead to the next slide. A CTA 2045, by contrast, is a physical port, and there's a picture there of a water heater. We've seen the most uptake of CTA 2045, and CTA is the Consumer Technology Association, and you'll see a physical port, but then a variety of protocols. So the CTA 2045 can actually read. It can get a Wi-Fi signal, it can get an OpenADR signal, it can get an SEP signal. So it's multi-protocol, the software side, and it's got a physical port. So you can retrofit a device, or you can get an EV charger or a water heater or a pool pump that has CTA 2045 available on it. It tends to be for individual devices. OpenADR historically has tended to be for larger systems like the energy management system or lighting controls at the commercial CNI. But there's some areas where they have both. So you have CTA 2485 with OpenADR, and it's quite a powerful package. Now, when you get to whole building controls like a SHEMS, a smart home energy management system, we have a challenge on the architecture for the devices to be integrated, and that's where there's a lot of research still needed. Go ahead to the next slide. Now this, I did see one typo here, a couple typos actually, but this is a quick look at around the country where we're starting to see the requirements for CTA 2045 and the requirements for OpenADR. So in Washington and Oregon, there's been a lot of look at electric water heaters, and those are both resistance and heat pump water heaters. So the heat pump water heater is a great example of a technology that's both efficient and flexible, whereas a resistance water heater may be flexible, but not necessarily efficient. So it's one of those policy challenges on what do we do in the water heating space. But if we have storage with a heat pump water heater and connectivity, that's a very powerful device. Energy Star is having new requirements around connected devices and the use of OpenADR. There's work on water heaters with Energy Star, AHRI 1380 and AHR 1430. We have a variety of standards that are coming out for HVAC systems that have CTA 2045 and or OpenADR. In California, Title 24 has had OpenADR requirements for large commercial buildings for several years in commercial HVAC. And there's also something called JA13 that has some requirements for CTA 2045 in water heating. So there's a variety of these requirements around the country. And let's go ahead to the next slide. Now I want to talk a little about the use of OpenADR in commercial and industrial facilities in California. Over the last 10 years, this is a summary of some of the incentives that have been paid out to buildings. So several hundred megawatts have been, automation for several hundred megawatts have been installed through utility programs. So these are investor-owned programs. And you'll see on the left it says customer paid and vendor paid. So several hundred customers, several hundred megawatts, and several 100,000 service accounts. And we've been collecting data on how the programs have changed over time. So the report that's listed here on Automated Demand Response Non-Residential Incentive Structure Research Project took a look at what the trends have been in the payments. California utilities have been paying a couple $100 per kilowatt to pay for an audit, a review of the flexibility technology strategies, review of automation, and installation of the automation to enable the buildings to be enrolled in some of the DR programs that I mentioned earlier. So we've been paying those incentives to allow that kind of technology to be integrated. Go ahead to the next slide. This slide shows you the performance of different strategies. Now I have lighting all the way on the left and general on the right. And what you'll see is the estimate, the y-axis is the estimate of the performance in the field from the mean event performance compared to the initial estimate, and the initial estimate was generated when the audit was done. So the lighting systems have performed better than the initial estimates. Some of the HVAC have not done as well. And as you know, there are big challenges in baselines when we look at the performance of an HVAC load shape and compare it to an individual estimate. They haven't performed as well on average, but still we're getting a pretty good capability. So there's a variety of different kinds of facilities here. In California, these incentives have gone out to commercial buildings, they've gone out to agricultural pumping, they've gone out to industrial control systems, and we're starting to look at, again, what is the performance of the different end uses. When we think about HVAC, we look at the last 10 days for the baseline, and it may be that the event day is warmer than the last 10 days, and we try to account for those in a morning adjustment in the baseline. But then sometimes you have to shed load just to break even. And so for HVAC, those baselines are still a challenge. Go ahead to the next slide. So I'm going to transition to my last few slides around the California Senate Bill 49, which is Appliance Standards in the State Water Project Assessment. I have 3 bullets here that explain the scope of it. I'm not talking here about the water part, although that is in the title of it. But the concept is that California is trying to explore the feasibility of requiring that appliances have the capability to be able to have flexible load. So the efficiency standards are, we want to manage energy loads to improve the grid reliability. And the CEC is looking at the requirement to require demand flexibility and prioritize appliances that have some capability to receive signals and provide flexible load. So the CEC is working with the PUC and the IOUs to consider what is going to be required to incentivize demand appliances. Go ahead to the next slide. Now this one is a really exciting concept here. And the idea is California is going to require digital prices, digital tariffs. So the long-term vision is that every tariff in the state is communicated in a digital format. And the utilities are interested in looking at how we can use OpenADR and some of the features in that standard to represent the integers associated with the tariff. So we care a lot about the shape of the tariff. It could be a time of use tariff. It could be a critical peak price tariff. It could be an RTP tariff. And the second element of this is looking at the watt time signal and the greenhouse gases. So we want to be able, if a customer wants, to listen to how clean the electricity is and control their devices to minimize the greenhouse gases associated with their consumption. So that we are in the process in California of looking at the automation technology required for this kind of system. And you'll see a list there: smart plugs, thermostats, energy management systems, EVs, batteries, water heaters, refrigeration. So this is an effort that's underway, and Andrew's leadership, Commissioner McAllister's leadership, has been a driving force in moving towards this prices to devices capability in California. Go ahead to the next slide. The load management standards are actually an open order institute rulemaking. And the Public Utilities Commission, of course, regulates the IOUs, but this rulemaking in California also is influencing the municipal utilities and all of the community choice aggregators. So this requirement that California requires that the utilities publish their tariffs in a digital form is for all energy service providers. And this technology is supposed to be potentially in real time in the future. So if you're getting an RTP signal, you'd get it continuously. Now, it may be that you have a day ahead price. So at 3 o'clock on Monday, you get 24 prices that give you the hourly price for the entire day. And that's kind of a rolling thing. And the concept is then you could schedule your heat pump water heater to charge before the high price time. And you could schedule your dishwasher not to come on until the price is low. Some of that may be manual, that you let people see the price, and they could get a smartphone app. So there's a lot of interest in creating the underlying infrastructure to allow this to be happening. Go ahead to the next slide. I am happy to say that we've been negotiating with the California Energy Commission for something called the CalFlexHub. The California Load Flexibility Research and Deployment Hub is an epic solicitation that LBNL had won the notice of proposed award, and we're currently negotiating. We have a series of partners from around the state and a set of technology projects, as well as partnering with the state on creating the infrastructure to test the ability to send out different kinds of prices. So we're working on valuing the load flexibility, prioritizing which technologies are the most promising to be able to receive a signal and respond to it, and creating both what's called low TRL, or sort of more science, more new technologies that aren't quite on the market yet, and technologies that are on the market that we can work with some of the vendors to modify the software for them to get this continuous price signal. Demand response today is still hot summer events, and we are looking towards trying to move it into an 8760 every hour a year opportunity. Of course, this matters a lot in the spring in California when we have our duck curve problem. And if we can use more electricity in the middle of the day and less around dinner time, we can flatten that duck, and we can understand how to invest in the technologies. We also have a disadvantaged community theme here. So we want to make sure that we're getting the technology out to customers and working with these communities that may be concerned about this time varying electricity prices. One of the things that we're doing there is using FM signals. So the concept of an FM signal is that a radio can be put with a device, and we can get those prices broadcast to devices, and not this two-way. OpenADR at this time is a two-way system, but we can also broadcast prices, and we want to look at being able to get to more rural and remote sites that may not have the internet, or somebody may not have Wi-Fi at their home. So we're going to create technology to try to get these prices distributed more broadly. Go ahead to the next slide. This is my final slide, and I want to just remind everybody that there's a lot of work going on in these different standards. And it's an exciting time because we've been working on these concepts for many years now. And the manufacturers and the service providers are starting to understand that this is a very cost-effective technology investment, because the devices themselves are getting much smarter. Some people want, a communicating refrigerator that can tell them what kind of groceries they need, or have some other smart devices on them. So we're starting to see these kinds of things in homes. But of course, those tend to be the high-income homes. We are looking at, I reviewed for you that many states are requiring communication on their devices, and California is making a very direct investment in the use of digital tariffs. I mentioned the need for cost-benefit data. And one of the issues is, do we have persistence of savings? In that study from Energy Solutions about the ADR incentives in California, there's some data on the persistence of savings, and many of the customers would participate for 3 or 4 years. But will they participate for 10 years? So when we make these investments in this technology, what is the lifetime of a gateway or a smart device? And that's a real important issue in the cost-benefit analysis, is how many years does this communicating device communicate? And are the programs stable enough that people will invest in the infrastructure? So we've seen a lot of change in the way the programs are structured, and that makes it confusing to customers. So we need simple enrollment methods. I think I have one more slide. This is just some of the questions. Go ahead to the very last one. Some of the questions that states can ask. It's really important to understand whether utilities are thinking about the steps towards promoting interoperability in demand flexible loads. What kind of automation standards do they want to invest in? How can we work with the state on the building codes and state load management standards like California is trying to do? And how do we think about planning or proposing grid modernization efforts to integrate flexible loads? Because the majority of the load out there is with buildings. About 70% of the electricity use in California, in the United States, is buildings. And we want to really enable those loads to be flexible so those peak loads don't really dominate the sizing. So we have a poll here. Does your state consider buildings as a grid resource? So we'll take a moment for you to fill that poll out, and look forward to your thoughts. I'll stop right there.
Great, thanks so much.